This is Brian Putt. Today I'd like to talk to you about a situation that sometimes arises where you have two different models and you want to be able to compare distributions from those two different models. And how can you easily do that? Another application might be I have a portfolio of assets, and each of those assets is sitting in a separate probabilistic model that may be being developed by different people. So how do you combine these into a single model? So in this particular case, I have a model here called apartment probability with inputs. And down here, there's a distribution called NPV. Then there's another model called the simple apartment probability model. And it has a discounted cash flow. So I'd like to be able to compare those two distributions. So what I'm going to do is to start up a new file, and in that file I want to put both of these distributions. So I'm going to go File, New, blank worksheet, and this will be comparison of two apartment models. Okay, let's do the simple one first. Simple model NPV. It's going to be equal to the index of, and then I need to go get the simple model. Here's the simple model. I go over to probability, the PM table. We'll go to the top, and we're going to highlight this particular vector, comma, PM index. The problem here is that I have not initialized this model. So I'm going to come over here and initialize to 1,000 things. And now I have my model. We can then define that, SIPmath, define outputs. And we can go to SIPmath graphs. And then we'll do the apartment new model. And it'll be equal to the index of, you have to do the probabilistic model. This is the probabilistic model. So let's go over here to the PM table. We'll go to the top. Here's that PMN. So we'll just highlight this, comma. This time it should just pop in here, PM index. Okay, there it is. There's that one, and we'll define that as an output. Then we'll graph this one as well. I'll take this, cut it, Control X, come over here, Control V, and now I have a comparison of these, and we'll do a little formatting. So what we see is that the new apartment model has a much wider uncertainty than the simple model. An advantage of doing it this way is that if I come and look at these equations, they're well documented. Here's the simple apartment probability model, original, and it tells me that the name is called D_DCF. That's the vector or SIP. And in this one, it's the apartment probabilistic with inputs with a vector name or a SIP name of D NPV. So I hope you find this example useful in perhaps generating a portfolio of things or just doing some comparisons. Thank you for watching.